Okay, so good afternoon, everybody. Mr. Shua coming at you again with another math video. Today, we're going to talk about simplifying radicals. This should be an easy topic for some, but it's not always easy. So hopefully, after watching this video, this will be an easy concept for you to master. Now, simplifying radicals. Your teacher may have taught you one of three ways, or maybe they've taught you two or three, or all of the three ways that I'm about to show. The first method I'm going to show is prime factorization method. So let's say you need to simplify something like radical 80. Okay, well, radical 80, doing the prime factorization way, that means that you're going to break it down to all of its prime factors and then simplify. So, for example, radical 80, I could break down as, say, radical 8, right? Move this, times, let me put this back up here, radical 10, because 8 times 10 is 80. But both radical 8 and radical 10 can also be broken down into factors. Now, radical 8, I could break that down into radical 4 times radical 2. Let me put this up here. All right. So that's radical 8, and then radical 10, I could break that down as, put this up here, this radical 2 times, come on, stay up top here, radical 5. Right? So I broke down the radical 8 as radical 4 times radical 2, and then the radical 10 as radical 2 times radical 5, but the radical 4 can be broken down. So what I would do, I can break the radical 4 down. Matter of fact, let me just copy this, make this easy on myself. Then I'll break this down here, radical 2 times, get rid of that. 2. All right, so it looks like we have everything broken down. So I started with radical 80. I broke it down initially as radical 8 times radical 10. I broke the radical 8 down as radical 4 times radical 2. I broke the radical 4 down as radical 2 times radical 2. Then with the radical 10, I broke that down as radical 2 times radical 5. And that doesn't break down any. So here now I have all prime numbers factored here. So I have radical 2 times radical 2 times radical 2. Let me put the times in here. Times, come on, times radical 2 times radical 5. Okay, but now here, radical 2 times radical 2, isn't that just 2? And then radical 2 times radical 2 again is also 2. Radical 5 doesn't break down any further, so then I would just simply have radical 5. So now I have 2 times radical 5. We know that 2 times 2 is 4, radical 5. So the prime factorization method for radical 80 would be 4 radical 5. Again, once we break it down by the prime factorization way. Okay, now let's look at another method that we can use in order to break it down. Another method we can use, which I call the nth root of products. Okay, so again, let's start with this radical 80. All right, now what I would suggest you do is find two numbers which are products of 80. One of the numbers, in this case, since this is the square root of 80, one of your numbers should be a perfect square. Well, two numbers that I can think of would be 16 and 5. Radical 16 times, come on, bring it back up here, 5. Because 16 times 5 is 80, and 16 is a perfect square. So now I know that the square root of 16 is 4. And then radical 5 does not simplify any further. So 4 radical 5 is my answer. So that's the second method, using the nth root of the products. Then I have one more method that I'd like to get rid of that. I'd like to show you, which is simply using your calculator, using your graphing calculator, TI-83 or TI-84. So if I turn my calculator on and I go to my stat plot, y equals, since this is the square root of 80 here, what I'm going to type in is 80 divided by x squared, because I want to know what the square root of 80 is, right? Now, what I'm going to do is I'm going to hit second key, table. I'm going to go to my table, and when I look in my table, I'm going to go to my Y1 column, and I'm going to scroll until I see the last whole integer in that column before everything goes all to decimals. Now, as I scroll down and look, I see everything seems to be decimals after 5 here. So 5 is the last whole integer in the Y1 column. When I go over to the X column, I see a 4. So by the calculator, 4 radical 5 is the simplification of the square root of 80. So again, the 3 methods that you have: prime factorization, breaking everything down. We also have finding the nth root of the products, breaking it down. We also have the calculator. Now, this doesn't just work for square roots. This also works for cube roots, fourth roots, fifth roots, sixth roots, whatever. And let me show you that. All right, so let me just go on to another page here. All right, so let me try another. Let me try, say, the square root. Matter of fact, no, not the square root. Let's try an nth root, so of something else. Third equation, and say a radical. Let's try the cubed root of 250. Come on. The cube root of 250. Okay, first, the prime factorization way. Well, prime factorization, the cube root of 250, I could break down as the cube root of 125 times the cubed root of 2, right? Because 125 times 2 does indeed give me 250. Then I could break down the cube root of 125 as the cube root of 5, right, times the cubed root of 25 times the cubed root of 2. Right? Because 5 times 25 gives me 125. Cube root of 2 cannot be simplified any further. Now, the cube root of 25, I could break that down even further. And I could make this, the cube root of 25 is basically the cube root of 5. Okay, times the cube root of 5 times the cube root of 2. So now prime numbers are all across here. The cube root of 5 times the cube root of 5 times the cube root of 5 times the cube root of 2. Now, since I have 3 of the 5s all the same, well then, The cube root of 5 times the cube root of 5 times the cube root of 5 is just 5. And then, since cube root of 2 can't be simplified any further, 5 cube root of 2. That's what it breaks down to, prime factorization, 5 cube root of 2. Okay, now method 2 was using nth roots. Okay, so cube root of 250. Again, now I would find two numbers which multiply to 250, and one of the numbers being a perfect cube. Well, it just so happens right up here, I could take the cube root of 125 times the cube root of 2, because 125 is a perfect cube. And I know this. Well, let me just go to my calculator. And then I can just go to math and option 4, the cube root of 125, which is 5. So the cube root of 125 is 5, and the cube root of 2 does not simplify any further. So using the nth roots, the cube root of 250 simplifies to be 5 radical 2. Then the third method would be on the calculator. So let me clear this. What I would do, I would go to my calculator. Let me clear this. The cube root of 250, I would type in 250 divided by x cubed, because I want to know what the cubed root of 250 is. Then I would hit second, table again, and then when I look in my table, if I look in my Y1 column, I see 2 is the last whole integer before it goes all to decimals. If I look at my x column, I see a 5. So on the calculator, the cube root of 250 breaks down to 5, the cube root of 2. Again, this works for 4th roots, 5th roots, 6th roots, any nth root. So again, with simplifying radicals, you have 3 methods. Prime factorization, breaking it down, finding the nth root of products, or using your graphing calculator in order to simplify radicals. Okay, so hopefully after seeing this video, you won't have any issues simplifying radicals. Okay, have a good day, and I will see you on the next video.